Thank you all for being here. My talk is going to be about high elevation fen restoration. So for our conference, we talk about restoration in the wildlands and at home. My part is in the wildlands. So this is historic work that's been going on at Mountain Studies Institute actually since 2008, with groundwork really beginning in 2012. And I'm going to be speaking about two different fens, one that has been a great success and one that we're still working on, including tomorrow if you're coming with me on the field trip. I do want to at least mention quickly that MSI, we're constantly growing and changing and evolving. And in the last couple of years, we've had a really brilliant hydrologist join our team named Dr. Jake Kurzweil. And so he is actually doing more fen restoration work beyond what I'm talking about today that's just actually kicking off this season. They've been at some kind of harder to get to sites that are part of the Bonita Peak Mining District. So if you're from here, this is like the area that is now being restored as a result of the Gold King mine spill that we had in 2015. So there is more fen work going on, and if you want to hear more about it, we have a sign-up sheet for our newsletter back at the Mountain Studies table. So please add your name to that if you're interested in knowing about our additional work. So here, I'm going to see, is the microphone still working if I'm here? Oh, they wouldn't be able to hear me? Okay. Well, I just quickly want to just point out on this map. So just to orient yourselves, the town of Silverton is down here. If you were in Silverton and started driving north on Highway 550, you would just go right past the Chattanooga Fen site that I'm going to be talking about. It's just right there, parallel to the highway. Ophir Fen, where we're going to be working tomorrow, which is part of this talk, you would go north on Highway 550 and then turn off at the Ophir Pass Road, which is a dirt road that goes up and over, and just off the map that you can't see, if you continued over that pass, you would end up in the small town of Ophir, which is kind of a sneaky way to get over to Telluride, just for orientation. Hopefully people on Zoom are able to hear me. So just rewinding, and this might be a review for a lot of people in the room, but just to make sure we're all talking about the same thing, I wanted to rewind and go back to what is a wetland. Let's have some audience part. Well, I already have it up there, I guess, but when you think of a wetland, there really are three things we think about. And when I talk about this with students, I say, picture if you had a little three-legged step stool or a round table with three legs. If we took one of those legs away, what would happen? It'd fall over. We would have it ceasing to function as a proper wetland. And so the terms that we use to talk about that are hydrology, soils, and vegetation. So hydrology, clearly we mean the water. So where is the water in proximity to the surface of the land? And maybe sometimes we have riparian peripheral wetlands. So we're having surface water that's going through the soil to keep that wetland wet. Soils, we talk about hydric soils, and here, wait, I'm just realizing I should be advancing these slides. So hydrology, yeah, must be wet. And so in the West, the definition is really that the soil is saturated for 2 weeks during the growing season. And that's sort of our regional definition here in our drier climate. And there's, that can come from groundwater, surface water, the fringe area of ponds and rivers, as I mentioned. So hydric soils, this is not something that we really have any control over. So when we talk about fen restoration, we're not changing the soil, but hydric soils are more an indicator of an active wetland. So we see the root channels that show sort of a rust or oxidated root channels, discoloration, dark soils, smell of sulfur. All these things indicate that we're truly in a wetland. And then finally, our favorite part as the Native Plant Society are the hydrophytic plants. So water-loving vegetation, and usually there's some adaptation to be able to keep their feet wet. And there are things that we think about as kind of very typical ones, like the hollow cells that are called a renkema in the roots of cattails, things like that. So when we have those three things, we know that we're in a wetland. And then and why are wetlands important? Like, why does everyone make such a big deal about wetlands? there are actually multiple things that wetlands are doing for us every day that we don't even realize. And so these are things like, we call them ecosystem services. So values of natural ecosystems that are helping the human environment. So flood control, because they store water, reduce sedimentation and reduction of pollutants in the flow of surface water, water storage, they are basically the sponges, and carbon storage as well. So they have a climate change benefit for us as well. And then we also think about wildlife habitat. CPW has a statistic, I've never really checked up on this, but that 90% of the wildlife in Colorado use a wetland for some part of their life cycle. So whether that's during their breeding time for extra cover or for water, just different parts of their life cycle. And then we know that these are biodiversity hotspots. Ross in his talk mentioned the sundews, those fun little carnivorous plants, things like that. So we know we have rare plants that are found only in wetlands. So this is kind of a fun little cartoon that illustrates that and why wetlands are important for us, that we have that. Is my pointer coming? So surface flow, the energy is dissipated as that water slows down and is stored in wetlands. We have groundwater flow, and we know that the plants in wetlands help with that breaking down of the contaminants. They mention critical wildlife habitat, and we know it's also critical rare plant habitat, and that we get cleaner water at the end. So the main take home here is filtration and water storage. So we've talked about wetlands. Now let's talk about what is a fen wetland. So there's a few different points here that would make this specific type of wetland special. And one is that the plant material does not fully break down. So we have an accumulation of partially decomposed matter over time, which we call peat. And so most people think of peat as something you use in your garden, or we think of peat bogs. And so bogs and fens are the peatland wetlands. These make up 50 to 70% of all wetlands in the world. And I've read statistics that say 2, and I've read 3% of the Earth's land surface. So globally, rather rare. More, we think about them as being present in boreal regions. And then the San Juan Mountains, of course, are very special that we have these rare fen, iron fen wetlands here in Colorado. So fens are different from bogs because they are fed by groundwater. We think of bogs as being fed by rainwater and are found in areas where rain is more abundant. But fens are groundwater fed specifically, and they can take thousands of years to develop. And the fens that are in the San Juan Mountains are estimated to be around 10,000 years old. And they figure prominently in all scenarios for carbon dioxide induced global change, because they are such an important sink of carbon dioxide, and they store that carbon in the soil. So why are we restoring these fen wetlands? These 2 specific ones that I'm talking about today were part of a mitigation effort. So without getting too far into the weeds, under the Clean Water Act, there's protections for wetlands. And if a wetland is damaged, like say in the construction of the real estate around Purgatory Ski Area, in this case, that's what happened. It's actually Purgatory Village Lands, which is the real estate development company associated with the ski resort. They are under a permit from the Army Corps of Engineers, and they had to mitigate fen wetlands at a 2-to-1 ratio. So in our case, they are restoring twice the acreage of fens that were damaged. And so this whole, everything I'm going to be talking about today is the result of an agreement between the ski resort with the U.S. Forest Service and the Army Corps of Engineers and Mountain Studies, and we've been using these as service learning sites for the last 12 years. So Chattanooga fen, this is the first one I'm going to tell you about, and we've really had great success here, and we consider this as a restored wetland at this point, that the permit is closed, and we've got this wetland functioning. We've put all 3 legs back together under our stool. So What we had to do, so thinking about those three pieces, the first piece was restoring the hydrology. And so to do that, what happened was there were ditches that had been dug through this area. So we had to first fill those ditches and put in some man-made check dams in order to slow that water down and get the hydrology functioning. So keep your eye on, you can hardly see this tree behind the piece of heavy equipment there. So these two trees are kind of going to be our visual points. And you can see that they did that construction, filling in the ditches. Quickly, I want to mention this material that you see stacked up back here that looks like hay bales. It's not straw. It's actually a material called excelsior. And if you could picture taking an aspen tree and running it through a spiralizer, this is the material you would get. So it's like a wood straw made from aspen, and it's really absorbent. It really soaks up water. And we were using this as kind of a surrogate for the peat that was removed whenever these ditches were dug many, many years ago, probably in the early 1900s. And so the first thing was, let's get that surface connected. So we've got that surface flow of the hydrology. And here you can see, I mentioned that tree. So I also, as I was putting these slides together, thinking this talk could be entitled "The Weaknesses of Repeat Photography Over Time," because you don't always get exactly the same angle, but this tree here is that tree that was behind the piece of heavy equipment. And so you can see our ditch as it was filled in. And then here 2 years later, here's that tree again, and just the greening up of this fen over time. And so not only did we have to restore the hydrology, we had to restore the hydrophytic vegetation. And we had many, many days of working with volunteers to plant seedling plugs of different sedges. And these pictures are from a day that we had the Colorado Native Plant Society's Southwest chapter out to help us. I think the only person who's here today that I know of is John Brager. He's right here in this green jacket, and he's right here, our field trip coordinator for the Southwest chapter. So he was there. And we had a lot of help getting hydrophytic back into our fen. And because this is the Native Plant Society, I'll let you know the species we used primarily was Carex utriculata. And I've always referred to that as Northwest Territory sedge. But as I was looking for a picture, I see that it's sometimes called swollen-beaked sedge as well. It has this beautiful corn cob-like inflorescence. It's really easy to collect the seed from. And so just a few more pictures we'll go through quickly of using the excelsior. And so what we do is we use the excelsior to restore the peat layer that was lost. And we also use it to sort of create an insulating layer around those plants when we put them in the ground. And so you can just see this kind of general green up. So here, I think what's going on here is this plywood dam is this plywood dam and is this plywood dam. So different perspectives, repeat photography. And so here's a image from the restoration of filling in those ditches with those hay bales of the aspen wood straw, we call it excelsior, and then covering it over and trying to get the hydrology and the vegetation restored. And then we know those hydric soils follow over time. So here's just one thing I wanted to mention about the Chattanooga fen. It's primarily flat, and that's really why this was a little easier for us to do. None of these fens are easy to restore because the growing season is so short in the San Juan Mountains. And, we've had really variable precipitation over the last couple of decades as well. But Chattanooga, it's kind of at the toe of a slope. And so that groundwater is all kind of settling out in this big flat area. And so we've had this really successful, really successful revegetation and green up. And it's really been fun to watch this fen restore and heal over these many years. Just as a side note, I joined Mountain Studies in 2015. So I wasn't a part of those very first years of restoration, but I've been kind of in charge of it since 2015. So the other fen, the one we're still working on, has been more of a challenge. It's a little higher. This is where we're heading tomorrow on our field trip. And you can't really tell on this map, but because topography is not indicated, but here's the road. And then this part of the fen is all kind of flat and the water really does settle. Again, there's this very steep slope above that coming down. And then this part of the fen is very steep and sloped. And so that's presented a challenge. And same story here. When we came upon this fen, there were ditches that needed to be filled in, a lot of brown bare area. And beyond that, there's an interesting thing that happens in these iron geologies. If you remember from chemistry class, sometimes you'd have a lab where you were putting different components together to see what kind of precipitate would fall out of solution. So in this environment, what happens is these are iron-rich fens. There's a material that's called ferrocrete that is almost like an asphalt parking lot. And so when that iron and the air mix, what we had in this brown area from this aerial image from 2012, there was actually this like hard impervious surface that was called ferrocrete. And so the first part of that restoration was breaking that up and getting us back to mineral soil so that we even could start to revegetate. So really interesting how the geology plays a part. So we keep on plugging away. And this is my silly play on words because we call these seedling sedges, we call these plugs. And so over the years, we've kind of changed we've been learning and growing as we've been restoring this fen and figuring out what works. When they first started, they were just doing transplants. When I say they, it's before I was a part of this organization, digging up sedges from the healthy part of the fen and bringing them over to where we needed to revegetate. But it's a really slow growing environment. So you're just leaving these kind of pock marks in the healthy part of the fen by removing those healthy sedges. And so we were like, let's figure out another way. We started collecting seed. At that time, we were working with a greenhouse in Buena Vista that actually closed during COVID. And I'm very sorry for that because they were wonderful to work with. And so we would collect the seed, send it to them. They would grow out our sedges and grasses and then send them back to us. And we would get these little plugs and plant them in the ground. As I mentioned, that Excelsior, that aspen straw wood, we use it to kind of tuck them into bed and keep them warm. And over time, whether it was something going on in the population of plants at Ophir-Fen, whether they were stopping producing viable seed, or if we just weren't getting the seed at the right time, we ended up having 0% germination rate in our seed crop. And so these days, I have actually been getting these kind of plugs from an aquatic and wetland nursery in Fort Lupton, Colorado. And so the seed is not collected on site. We haven't been able to do that. We're going to try to do it again. So the objective for tomorrow is to collect seed. Depending on how good of a seed crop we get, we're going to send some to the nursery to grow out, and I'm going to save some, and we're going to try to just seed it ourselves. So constantly learning with this fen. The species that we focus on replanting here are water sedge, Carex aquatilis, and Carex microptera, which is small wing sedge, and then 2 facultative wetland grasses, so Calamagrostis canadensis and Deschampsia cespitosa. So these are the 4 main species we've been planting at Ophir-Fen. So here's some fun pictures to see our progress. So as I mentioned at this first part, when we looked at the map, the top of the fen is really kind of flat, and we do get that water settling out and ponding up. And so this is kind of that top flat area, and it has been really successful. This is where we're going to collect seed tomorrow. But yeah, what a difference. And then again, this is the top kind of flat area. So for visual, here's this knob. That knob is here. And it's interesting because some of the spruce are doing more poorly as the waters come back up. You see those trees are kind of doing worse, but our wetland plants are doing better. And so here's the not so good part. This is that steep slope I talked about where the water really doesn't settle out. And, you know, from the beginning, we have made some progress, but it's not that beautiful verdant green that we'd like to see. And again, so this is like basically these two pictures are looking downslope and looking upslope from generally the same area. That excelsior, sometimes we use it in those straw bales. Sometimes we use it in this form of these, we call them wattles, or they call them excelsior logs, to help with erosion control. And we're actually going to be doing a little bit of that work tomorrow as well. So thinking about the problems and kind of troubleshooting, what are we missing and well, there's one thing that was not in our control. There was a wildfire on this fen. In 2021, I was on vacation and got the call that my fen had burned. But we talk about climate change and different indicators of climate change. This is a wetland at 11,000 feet, and it caught on fire in September, like when we should be weeks away from snow. So these are the kind of climatic factors that are probably influencing our fen, that it just is getting warmer and drier. And so this fen that was formed over 10,000 years of accumulation of vegetative matter, maybe the future is just different for it because the climate is different. Then also, there could be some change in hydrology that we're not picking up on. And there's a lot more to this story that I'm leaving out to talk about 12 years of restoration in 15 minutes. But we do have annual monitoring of groundwater using groundwater wells, and we have vegetation plots, and those data have shown different things. So perhaps there's a change in that groundwater flow, but I do see you can tell that the water table is close to the surface when you're just digging to do the plantings, but there might be some bigger change upslope or downslope of us that has changed the way groundwater is influencing our wetland. And also those drought conditions. We look at our, there's several remote area weather stations, or RAWs, that are around that we use the data from to when we write our report every year and see like how is this different from historic conditions. And there's also been a change in topography over time. If you go there tomorrow, you'll be able to see it for yourself, but fens tend to go in sort of, they call them stringers and flarks. And flark is I guess, Norwegian or Swedish word, but you tend to see this terracing in fens. And over that time of, when the ditching had been done, all that erosion that occurred, we really don't have that terraced topography in our fen anymore. And so trying to restore that is very difficult or impossible. And it probably will happen over, the next 10,000 years, but it's just a little different because that terracing isn't there. So we've tried a few different solutions. We're constantly experimenting. We had done some intense seeding and put this excelsior, this different type of excelsior blanket over top, and then decided that that was maybe just inhibiting the light from getting to the seed. So then we actually took the excelsior blanket back up, and we just started trying different things with erosion control. We've tried using a technique that's called one rock dams that actually is from indigenous practices. And we did a few rows of that with some volunteers last summer, and I think it's working pretty well. And I'm also trying to shift more to those facultative wetland grasses and away from those obligate wetland sedge species. So here, I didn't have a great picture of the one rock dam. It's really doing a good job catching sediment, but you can kind of see those. So we had our straw wattles in place, and then we're reinforcing them with these one rock dams. So that was just a picture I took 2 weeks ago. And lastly, I just want to mention that this work is the result of many, many partners working together. Dr. Rodney Chimner from Michigan Technical University wrote our original restoration plans and continues to help us with our fen restoration. He's used our work to publish papers. So the research on fen restoration that's being done here can have an influence in other places. We've worked together with several federal land management agencies, of course, Purgatory Ski Resort. The National Forest Foundation has funded a lot of this work, the Army Corps of Engineers, and we continue to inform restoration. And we especially want to thank our many, many volunteers who have put their hands to the ground and put these plants into the ground. And we're grateful for whoever's coming with us tomorrow as well.